Welcome students to this short video on Unit 9, Lesson 1, Example Problems. I'm going to show you how I work the example problems from the lesson material, and if you get something from how I work a problem, fine, use it in your work, okay? If you're doing fine without this, well then great, you know the material, which is the whole purpose anyway. All right, let's get going. Okay, so we're going to call this this one Lesson 1, Example 1. Okay, if you're following along. Well, good triangle. I have a habit of redrawing the triangles. Now, I'm going to call this angle A, and we know here that this is 8, this is 15, and this is 17. So the question is, what is cosine of A? Cosine of A. Well, we know cosine is what? Sa-ca, okay? So that's going to be adjacent, which is 15, over the hypotenuse, which is 17. Now, I usually round my sides to 2 decimal places and my angles to 1 decimal place in degrees. So hopefully that helps you out. Okay, let's take a look at example 2. Now, what I try to do is draw the picture myself. I sort of own it that way, if that makes any sense, okay? So here's a triangle, and I'm going to call this corner over here C. That means that the 5 is over here, and you got to be careful how you orient it. So since this is side B, like little b, I'm going to call this big B, and that leaves A up here at the top. And remember, this is little a. Now, all of these numbers are given to you. So little a this is 4, and then this other guy is 3. And what it wants to know is, it wants to know what's the cosine of A. It wants to know what's the sine of A. It wants to know what the cosine of B is. It wants to know what the sine of B is. Well, the cosine of A, remember, I'm right here in this angle. Adjacent over hypotenuse, 3 over 5. Okay, sine of A. Here I'm getting at A. The opposite is 4 over hypotenuse is 5. And then cosine of B. Well, now I'm right here. Okay, I'm right here in like this room, right? Okay, and it's a 3-sided room, so cosine is adjacent, which is 4 over hypotenuse. And then sine of B is going to be 3 over 5. Now, if you notice real carefully that the cosine of A is the sine of B, and the sine of A is the cosine of B. These are called co-function identities, and hopefully that makes some type of sense to you. All right, folks, let's see. I'm going to pick a different color here. All right, example 3. Now notice they give you this triangle here, but I'm going to redraw it, okay? I'm going to redraw it like this. Okay, this is B, this is A, and this is C. Now remember, this is 30 degrees. We know that this side is 7, and we don't know, remember, this is little b and this is little a. Now, this is a very, very important skill in trigonometry. It's called solving a right triangle. When we say solving a right triangle, we want to know all 6 things. We want to know all the angles and all of the sides. So let's see. Well, first of all, we could tell right away that the angles. So angle C is 30 degrees. Angle B is 90 degrees. And angle A is, well, remember, all of the angles in a triangle add up to 180. So I've already got 120, so that must be 60. Okay, let's write a side that we know. We know side C is 7. Now I'm sort of stuck, okay? I don't know these other sides. So I'm going to have to use my right triangle trig to be able to work this problem. And so this is what we're going to do. Let's start with the 30 degrees. We know the sine of 30 degrees is equal to opposite over hypotenuse. Oh, wait a minute here. I could solve that. I'm going to cross multiply, and I'm going to go like this. I'm going to go b times sine of 30. I'm just going to write it. B sine 30, okay, is equal to 7 times 1, which is 7. So b is equal to 7 over the sine of 30. Now, I would just put that in your calculator the way it is, but don't forget to close your parentheses after this 30 at the bottom, okay? Try to be neat about that. And when you do that, you will get, for side B, you will get 14, okay? So now I know B is 14. Okay, how can I find A? Good question. Well, we could use Pythagorean theorem. A squared plus B squared equals C squared, but in this case, really isn't B the longest side? So B is just the square root of the other side squared. 7 squared. I wrote that in the wrong spot. Or did I? Hold the phone. B was 14. We got that. We already have B. We're trying to find A. So A is equal to the square root of B squared, which is 14 squared, minus the 7 squared. And so A is equal to, what's that, 196 minus 49? So I think that is the square root of 147. 147. And like I said, I round mine to 2 decimal places, 12.12. So this is 12.12. Now that skill of being able to get all of these answers for a right triangle is going to prove extremely helpful all the way through the rest of this Unit 9. And so be mindful of that. Make sure you get that procedure down. Okay, you don't have to do it on all of the problems, but whenever we say solve a triangle, that is an important skill that will be very helpful. Okay, so let's look at this example 4. Example 4. It's a question about a height of a tree. Okay, let me pick a different color here. All right, so example 4. And the question is, I'm 30 feet away from a tree and I'm measuring up at an angle 57 degrees to the top of the tree. That's called an angle of elevation. So again, I'm going to draw this triangle myself. Okay, so this angle is 57 degrees. The height of the tree I don't know, but this is 30 feet. Now, keep this in mind. What trig value involves the adjacent and the opposite? That would be TOA, correct? So I'm going to say tangent of 57 degrees is equal to the opposite over the adjacent. I'll leave off the feet for right now. Let's cross multiply. Set it up as a proportion. H is equal to, I always put the side first. The side first, and then this second. Now just plug that in your calculator. After you put it in your calculator, you should get the height is going to be 46.20 feet. Okay, so make that a little clearer. And that's how you do example 4. Okay, folks, this is example 5, and I like this. This is a little bit of a challenge, okay, a slight challenge. So, of course, you could read the question. Someone's standing on top of this building, and they want to know how high this building is right next to it, okay, this this building right here. Okay, how tall is this building? Okay, and so they're looking down at 20 degrees from the horizon. Here's the horizon right here. Okay, and they can see the bottom of this building, and then they're looking up, and then they're looking up this way to the top of the building at 42 degrees. And the question is, how tall is the building? That is a very good question. Now, if you want, you could redraw the building, and I suggest that maybe you do that. One thing that we do know, the height is equal to the pieces on the left side here. Let me get a different color. The height of the building is equal to the sum of these two parts. What's the bottom part? It's 100. So that's going to be 100 plus A. Boy, if we could just find A, we'd be in good shape. Let's start with that bottom triangle. Now notice on this bottom triangle, this is X, this is 100, and I have this angle right here, 20 degrees. Hey, that's tangent. Tangent of 20 is equal to opposite over adjacent. I would cross multiply, and so X is going to be equal to 100 divided by tangent of 20 degrees. Now you have to do that on your calculator. When you do that, you get X is equal to 274.75, it's feet, right? Okay. All right, well, can we use that information to find A? Because that was our mission, right? Well, again, here's a picture. This is A. This is this X, which is 274.75. And we have the angle right here is 42 degrees. Now remember, 42 degrees is close to 45, so expect an answer around 270. All right, so what are we going to do? We're going to go tangent of 42 degrees is equal to opposite over adjacent. Remember that was 274.75. Now, after you do this about 10 times, it's going to be easy for you to figure this out. A, which is what we want, is equal to tangent of 42 degrees times 274.75. When I do that, I get 247.39. 247.39. But wait a minute, we want to know the height of the building. So the height of the building would be another 100, 347.39 feet. Okay, so that's how you do that problem. Okay, remember, the more you do these problems, the more you're going to be able to do later. And that, my friend, is that's a very helpful thing. So please be mindful of that. And I wish you well. Take it a step at a time. And after you do a few problems, you'll get the procedure down. And you'll be amazed at what you could do. Hope that helps you out.